Hey students, this is lesson 12.1. We're going to learn about tangent lines. We're going to use the properties of a tangent to a circle. This is a different tangent than the trig tangent, just so you know that. Go ahead and do this review and you can check back. Okay, so here's some theorems, and I hope you read the definition of a tangent, very important there. But if the line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. If a line in the plane of a circle is perpendicular to its radius at the endpoint on a circle, then the line is tangent. If two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So that would be these two are congruent because they're both tangents. We have OK is perpendicular to DF. So we're going to have here, using these theorems, line DF is perpendicular to segment OK, which is a radius. And we also have that DF is tangent if the two lines are perpendicular. And we also have that segment AB is congruent to segment BC. All right, so we're going to use these properties to solve some problems here. So if AD and AG are tangent to circle O, what is the value of X? Okay, now we just learned that if these 2 points are tangents, then these are perpendicular segments. So we know now, out of this quadrilateral, we know 3 of the angles. And we know that all the angles of a quadrilateral will add up to 360. So we're just going to add x plus 90 plus 90 plus 152 to get 360. And so x equals 360 minus those 3 angles, and that gives us 28. All right, I'll let you try that. All right, we're going to use this idea to help us solve this problem. It says Jasmine is riding in an airplane at an altitude of about 6.5 miles above the Earth. How far on the Earth can she see? If the radius of the Earth is 4,000, so let's say this is the Earth. Here's her airplane above the Earth up here. She can see to a point that's tangent to her airplane. So there's her airplane. And either way, either side she could see. We only need to know one of those to solve this problem, so I'm going to erase that one. All right, and we also know that from the center of the Earth to this point here, that would be 4,000 miles. That's the radius. And we know that this is a right angle because it's a point of tangency. And so we have a right triangle. We know that this part here is 4,000. And this is a little bit out of scale, but we now know that this is 6.5 because that's how high above the Earth she is, right there. So we have a right triangle, so we're going to use Pythagorean theorem. And the legs are 4,000 and our missing distance. And the other distance is 4,000 and 6.5. So we'll square that. So that means that d squared is equal to 4,006.5 squared minus 4,000 squared. And so d is equal to the square root of that, which is about 228 miles. All right, go ahead, you try that. All right, what is the value of x? Again, we're going to use that idea that if the if we have a tangent, and we know we have a tangent here because it's a right angle, so we know R is a tangent. And so we have a right triangle, and we can use Pythagorean theorem here. We're going to label the two legs. So we have two legs. So our leg squared plus our leg squared is equal to our hypotenuse squared. And an expression for one leg is just x. Substitute x in there for that. And for our other leg, it's 24. And for our hypotenuse, we can use the expression x plus 18. Now, x squared, 24 squared simplified is 576. Now, here's where we have to remember back to when we were squaring binomials. And remember, we'll use the FOIL method if you want on that. So that would be x squared for those two, and then the outers would be 18x, the inners would be 18x, so plus 36x, and the last two would be 18 times 18, which is 324. All right, and then let's subtract x squared from both sides, and so we now have 576 equals 36x plus 324. Subtract 324 from both sides, and we get 36x equals 252, and divide 252 by 36, and we get x equals 7. I'll let you try that. All right, problem 4 here. We want to know if this is a right angle. So, and if it is, then actually we want to know if it's a tangent, and the way we would tell is if this is a right angle. And the way we can tell if that's a right angle is by using the converse of Pythagorean theorem, which says that if a squared plus b squared equals c squared, then the angle is a right angle, it's a right triangle. So what we want to do is check that. So we want to do 5 squared plus 12 squared, and see if that's equal to 13 squared. So we get 25 plus 144, and that's equal, and that proves that it's a right triangle. And so we're going to say yes. We'll say MN is perpendicular to NP by the converse of Pythagorean's theorem. And then we can say that MN is tangent to circle P at N by the theorem that says if you have perpendicular lines, then you have a point that's tangent. And I think that was the third one, or the second one of the three theorems. All right, so you can go ahead and try that. Actually, we're going to apply the last of those theorems to figure out the perimeter here. And basically what that says is that if two lines are tangent, then the distances to those points of tangents from a point outside the circle are equal. And the fact that OS is inscribed, that tells us that LN, segment LN, NM, and segment LM are tangents, because that's what inscribed means. So by definition of inscribed, so we know that. And so we get that LO is equal to LR, and we also have that ON is equal to MT. And we also have that TM equals MR. All right, and that's by that third of those three theorems. And so because of all that, we can say that, and we also know that Ln plus Nm plus Lm is equal to the perimeter. And we know that Ln, this one, is equal to Lo plus On, which is now 8 plus 5. And Nm is equal to 5 plus 14. And Lm is equal to 8 plus 14. So if we add all those up, we're going to get the perimeter, which is 50. All right, I'll let you try that. And lesson check. That's the end of the lesson. I'll see you tomorrow.